In this video, you're finally going to move out of the playground folder and we're going to start playing with Mongoose. We'll be connecting to our MongoDB database, creating a model, talking about exactly what a model is, and finally, we'll be saving some data to the database using Mongoose. Now, we're not going to need any of the files we currently have open from the playground directory, so we can go ahead and close them. We're also going to wipe the to-do app database using RoboMongo. The data inside of here is going to be a little different than the data we'll be using going forward, and it's best to start with a clean slate. Now, there is no need to create the database after you drop it, because if you remember, MongoDB is going to automatically create the database once you start writing data to it. With this in place, we can now explore Mongoose. And the first thing I always like to do is check out the website. You can check the website out by going to mongoose.js.com. Here you can find examples, guides, a full list of plugins, a ton of great resources. The Read the Docs resource is the one I use the most. It includes tutorial-like guides that have examples, as well as documentation covering every single feature of the library. It really is a fantastic resource. If you ever want to learn about something or use a feature we don't cover in the course, I highly recommend coming here, taking the examples, copying and pasting some code, playing around with it, and figuring out how it works. Now, obviously, you bought this course for a reason. We're going to be covering most of the essential Mongoose features right now. The first thing we need to do before we can actually use Mongoose in our project is install it. Over in the terminal, I'm going to install it using npm I. npm I being short for npm install. The module name itself is called Mongoose, and we'll be installing the most recent version available at the time of this filming. That's going to be version 4.5.9. And we are going to tack on the save flag since we will need Mongoose for both production and testing purposes. Now, once we run this, it's going to go off and do its thing. We can move into Atom and start creating the files we're going to need to run our application. First up, let's make a directory in the root of the project. This directory is going to be called server, and everything related to our server is going to get stored in here. The first file we're going to create is going to be called server.js. This is going to be the root of our application. When you want to start up our Node app, you're going to run this file. This file will get everything ready to go. The first thing we need to do inside of server.js is load in Mongoose. We're going to make a variable called Mongoose, which I always seem to spell incorrectly, and we're going to require it from the Mongoose library. Awesome. Now that we have the Mongoose variable in place, we need to go ahead and connect to the database because we can't start writing data to the database until Mongoose knows how to connect. And the process of connecting is going to be pretty similar to what we did inside of our MongoDB scripts. For example, the connect script. Here we called Mongo client.connect, passing in a URL. What we're going to do for Mongoose is call mongoose.connect, passing in the exact same URL. MongoDB is the protocol, // we're going to be connecting to our local host database on port 27017. Next up is going to be our / followed by the database name, and we'll continue to use the to-do app database, which we used over here in the script. Now, this is where the two functions differ. The Mongo client connect method takes a callback, and that is when we have access to the database. Mongoose is a lot more complex. This is good because it means our code can be a lot simpler. Mongoose is maintaining this connection over time. So imagine down here, I tried to save something. Save new something. Now, obviously, by the time this statement runs, Mongoose Connect is not going to have had time to make a database request to connect. That's going to take a few milliseconds at least. This statement is going to run almost right away. Behind the scenes, Mongoose is going to be waiting for the connection before it ever actually tries to make the query. And this is one of the great advantages of Mongoose. We don't have to micromanage the order things happen in. Mongoose takes care of that for us. Now, there is one more thing I want to configure just above mongoose.connect. We've been using promises in this course, and we're going to continue to use them. Mongoose supports callbacks by default, but callbacks really aren't how I like to program. I prefer promises as they're a lot simpler to chain, manage, and scale. Right here, we're going to tell Mongoose which promise library we want to use. Now, if you're not familiar with the history of promises, it didn't used to always be something built into JavaScript. Promises originally came from libraries like Bluebird. It was an idea a developer had, they created a library, people start using it, so much so that they added it to the language. Right here, we need to tell Mongoose that we want to use the built-in promise library as opposed to some third-party one. We're going to set mongoose.promise equal to global.promise. And this is something we're only going to have to do once. These two lines, we're just going to put in server.js. We don't have to add them anywhere else. And with this in place, Mongoose is now configured. We've connected to our database and we've set it up to use promises, which is exactly what we want. The next thing we're going to do is create a model. Now, as we talked about, inside of MongoDB, your collections can store anything. I could have a collection with a document that has an age property and that's it. I could have a different document in the same collection with a property name. That's it. These two documents are different, but they're both in the same collection. Mongoose likes to keep things a little more organized than that. What we're going to do is create a model for everything we want to store. In this example, we'll be creating a to-do model. Now, a to-do is going to have certain attributes. It's going to have a text attribute. We know that's a string. It's going to have a completed attribute. We know that's a Boolean. These are things we can define. What we're going to do is create a Mongoose model so Mongoose knows how to store our data. Right here, let's make a variable called uppercase T to-do. And we're going to set that equal to mongoose.model. Model is the method we're going to use to create a new model. It takes two arguments. The first one is the string name. I'm going to match the variable name on the left, uppercase T to do. And the second argument is going to be an object. And this object is going to define the various properties for a model. For example, the to-do model is going to have a text property. So we can set that up right here. Then we can set text equal to an object and we can configure exactly what text is. We can do the same thing for completed. We're going to have a completed property and we're going to want to specify certain things. Maybe it's required. Maybe we have custom validators. Maybe we want to set the type. And we're also going to add one final one, completed at. This is going to let us know when a to-do was completed. Now, a created at property might sound useful, but if you remember the MongoDB object ID, that already has the created at timestamp built in. So there's no reason to add that here. Completed at, on the other hand, is going to add value. It lets you know exactly when you completed a to-do. From here, we can start specifying the details about each attribute. And there is a ton of different options available inside of the Mongoose documentation. For now, though, we're going to keep things really, really simple, just specifying the type for each. Text, for example. We can set the type equal to a string. It's always going to be a string. It wouldn't make sense if it was a Boolean or a number. Down below, we can set a type for completed. Completed needs to be a Boolean. There's no way around that. So we're going to set type equal to uppercase B Boolean. The last one we have is completed at. Now this is going to be a regular old Unix timestamp, which means it's just a number. So we can set the type for completed at equal to number. Excellent. With this in place, we now have a working Mongoose model. It's a model of a to-do that has a few properties: text, completed, and completed at. Now, in order to illustrate exactly how we create instances of this, we're going to go ahead and just add one to-do. We're not going to worry about fetching data, updating data, or deleting data, although that is stuff that Mongoose supports. We'll be worrying about that in the next videos as we start building out the individual routes for our API. For now, we're going to go over just a very quick example of creating a brand new to-do. I'm going to make a variable called new to-do, although you could call it anything you like. The name here is not important. What is important, though, is that you run the to-do function, which is right here. This is what comes back from mongoose.model as a constructor function. We want to add the new keyword in front of it because we're creating a new instance of to-do. Now, the to-do constructor function does take an argument. It's going to be an object where we can specify some of these properties. Maybe we know that we want text to equal something like cook dinner. Right here, we can specify that. Text equals a string, cook dinner. Excellent. And now we haven't required any of our attributes, so we could just stop here. We have a text property that is good enough. Let's go ahead and explore how to save this to the database. Creating a new instance alone does not actually update the MongoDB database. What we need to do is call a method on new to do. That's going to be new to do.save. New to do.save is going to be responsible for actually saving this to the MongoDB database. And save returns a promise, which means right here we can tack on a then call, and we can add a few callbacks for when the data either gets saved or when an error occurs because it can't save for some reason. Maybe the connection failed, or maybe the model is not valid. Either way, for now, we'll just print a little string, console.log, unable to save to do. Up above in the success callback, we're actually going to get that to do. Right here, I can call the argument doc and I can print it to the screen. Console.log, I'll print a little message first, saved to do, and the second argument will be the actual document. And now that we have this in place, we are done. We've configured Mongoose connecting to the MongoDB database. We've created a model specifying the attributes we want to-dos to have. We created a new to-do, and finally we saved it to the database. I'm going to add a semicolon at the very end, and we're going to run the script from the terminal. I'm going to kick things off by clearing the terminal output, and we're running node. The file we're running is in that server directory, and it's called server.js. When I run the file, what do we get? We get saved to do, meaning that things went well. We have an object right here with an ID property as expected, the text property, which we specified, and this __v property. __v is version, and it comes from Mongoose. We'll talk about it later, but essentially it keeps track of various model changes over time. For now, it's not important. It can be ignored. If we open up RoboMongo, we're going to see the exact same data. I'm going to right-click the connection and refresh it. Here we have our to-do app. Inside of the to-do app database, we have our to-dos collection. Notice that Mongoose automatically lowercased and pluralized to-do. I'm going to view the documents, and what do we have? We have our one document with a text equal to cook dinner, exactly what we created over inside of Atom. Now seems like a pretty good time for a challenge. We have one to-do created using our Mongoose model. What I want you to do is make a second one filling out all three values. That means you're going to make a new to-do with a text value, a completed Boolean, go ahead and set that to true, and a completed at timestamp, which you can set to any number you like. Then I want you to go ahead and save it, print it to the screen if it saves successfully, print an error if it saves poorly. Then finally run it. Make sure it shows up in RoboMongo and the data looks correct. If it does, you're done. That's your challenge, so take a moment, pause the video, create a new to-do, and when you're done, click play. Hopefully you were able to get that done without too much trouble. The first thing I would have done is made a new variable down below. I'm going to make a variable called other to-do, setting it equal to a new instance of the to-do model. From here, we can pass in our one argument, which is going to be the object, and we can specify all of the values. I can set text equal to whatever I like, feed the cat. I can set the completed value equal to true, which I wanted you to do. And I can set completed at equal to any number. Anything lower than 0, like -1, is going to go backwards from 1970, which is where 0 is. Anything positive is going to be where we're at, and we'll talk about timestamps more later. For now, I'm going to go with something like 123, which would basically be 2 minutes into the year 1970. With this in place, we now just need to call save. I'm going to call other to do.save. This is what's actually going to write to the MongoDB database. I am going to tack on a then callback because I do want to do something once the save is complete. If the save worked, we're going to get our doc, and I'm going to print it to the screen. I'm going to use that pretty print system we talked about earlier, JSON.stringify, passing in the actual object, undefined, and 2. Excellent. You didn't need to do that. You could have printed it in any way you like. Next up, I'm going to print a little message if things go poorly. Console.log, unable to save. and I'll pass along that error object, so if someone's reading the logs, they can see exactly why the call failed. With this in place, we can now comment out that first to-do. This is going to prevent another one from being created, and we can rerun the script running our brand new to-do creation calls. Right here inside of the terminal, I'm going to shut down the old connection and start up a new one. This is going to create a brand new to-do, and we have it right here. Text equals feed the cat. Completed is the Boolean true. Notice there's no quotes around it. And completed at is the number 123. Once again, no quotes. I can also go into RoboMongo to confirm. I'm going to refetch the to-dos collection, and now we have 2 to-dos. On the right-hand side of the values, you'll also notice the type. Here we have int32 for completed at and the property. The completed property is a Boolean, text is a string, and the ID is an object ID type. There's a lot of useful information hidden inside of RoboMongo. If you want something, they most likely have it built in. That is it for this one. We now know how to use Mongoose to make a connection, create a model, and finally save that model to the database. Stay tuned. I will see you soon.